Welcome to another unit of the ISM Statistics 1 exercise set, this time with an exercise on linear regression. Let's take a look at the exercise. A sample of music videos from YouTube is analyzed. It is assumed that a linear effect exists from the number of viewers in 10,000 on the number of likes in 1,000. A. Calculate the coefficients of the linear regression line that describes the relation between the two variables. B. Interpret the coefficients calculated in part A. C. Calculate the coefficient of determination R squared. Well, let's start with the first part and work our way through it. In the beginning, we take the table from the dataset. As we mentioned, likes depend on views. So likes can be called y as the dependent variable and viewers are x, the independent variable. So we need to extend our table by first adding 3 new rows. In the first row we put x squared, so 20.7 to the power of 2, 213.4 to the power of 2, and so forth for all the 5 values. Then in the next row we do the exact same thing but for y, so 1.4 to the power of 2, 25.8 to the pour of 2, and so forth. And finally in the third row we calculate x times y, so 20.7 times 1.4 giving this 113.4 times 25.8, and so forth. However, we are not interested in these values by themselves, but we want them to calculate the sum of all 5 videos, generating these numbers, so that in the final step we can divide them by 5, the numbers of observations. So here we have 5 videos, so 5 observations, that we get the average amount. So the average number of views is 70, the average number of likes is 8.4, and the average of x squared is 11,502.16. The average of y squared is 171.23, and finally the average of x times y is 1,401.94. Having done these preliminary calculations, we can start with the first part of our exercise, calculating the coefficients of the regression line. Why did we all this work? Well, if we take a look here at the formula for the slope of the regression line, we see that can easily be calculated by first taking the average of x times y. This is the 1,401.94, and subtract the average of x times the average of y. So subtract 70 times 8.4. All of this is then divided by the average of x squared. Here in this example it's 11,502.16 minus the average of x squared, so 70 squared. We insert these values, calculate the expression, and we get a slope of 0.1233. What does this mean? Well, we said that the viewers were in 10,000, the likes were in thousands. So for every 10,000 additional viewers, we get roughly 124 additional likes. This coefficient can halfway decently be interpreted. Looks a little bit different when we're going to interpret the intercept. First we need to calculate this. So the intercept is calculated as the average of y minus the slope we just calculated times the average of x. So we have 8.4 minus 0.1233 times 70, resulting in minus 0.231. And here we see that this is relatively problematic to be interpreted, because this would mean if I have 0 viewers I would get minus 23 likes. This, well, obviously doesn't make so much sense. Therefore, well, slope usually can be interpreted in a halfway sensible way, intercept not always. So that's the case here. In this case we have some problems in interpreting correctly the intercept. Well, but this is no big problem because, well, we finished part A and we already also finished part B. So we can do some additional work and start working on part C, the coefficient of determination. For this we need this additional line, this additional row with the y hat to the power of 2. What's y hat? That's if I insert x into the regression line. So here I would insert 20.7 in the regression line, so I calculate 20.7 times 0.1233 minus 0.231, and then I square the result. So I see here the result of this would be 5.3884. Then I do the same thing for the 213.4. I insert this, so I multiply this with 0.1233 minus 0.231, and the result is squared, giving me a result of 680.229. And we do the same thing for all 5 observations, and as before we sum them up and divide them by 5, giving us the average value. So we see here those values are actually pretty close to the y-squared values, and that's where we are going to compare them with. The y-squared gives us something like the overall variance, whereas the y-hat squared gives us something of the explained variance. We'll see this on the next slide. Here in the next slide, considering the coefficient of determination, we use the following formula. And here you can see what I just mentioned. We basically compare on the upper part what we can explain. So we consider here the y-hat squared and its average. So here we insert the 170.9316 minus the squared average of y, so 8.4 to the power of 2, and below the fraction line we have the overall variance, which is represented here with y squared, and of this the average. So here we put 171.23 minus 8.4 to the power of 2, resulting after 2 steps to a value of 0.997. So this value then gives us the share of the variance of y, which can be explained via the regression line. So the regression line we have just calculated on the previous slide, can explain up to 99.7% of our variance in the likes by just using the information of the viewer numbers. Well, this then already concludes this exercise. I hope you enjoyed listening to it and learned something while doing so. Until next time, see you and goodbye.